perpendicular to this plane. Assuming that this is the plane N and that is the point P. Through point P, there is a line L which is perpendicular to the plane N. And through that point P, we can create a two lines. The line 1, assuming that there is a line 1 and a line 2. Therefore, it determines a plane because according to theorem 2 that a plane is determined by two intersecting lines. And through that intersecting line there is a plane, so we can call that as plane N. And that plane N cannot meet this plane M, so plane N and plane M are parallel. Theorem 12. Through these two skew lines, there is only one plane parallel to this line. So this could be our line 1, and this line would be our line 2. And this line here would be our line 3. So this line 1 and line 2 intersect. So they determine a plane. Because according to theorem 2 that a plane is determined by two intersecting lines. And these two intersecting lines is assuming that this is the plane N. So this plane N is parallel to this line 3 because according to statement 87 that a line is a part of a plane, which states that if a plane do not meet a line or a line do not meet the plane, then they are said to be parallel. Through this point, the intersection of the line 3 and line 4. Assuming that this line here, this is the line 1, and this line here is the line 2, and this is the line 3 and the line 4. So the intersection of the line 3 and the line 4 is the point P, which these two lines determines a plane, which is the plane M. So this plane M is parallel to this line 1, because this plane and that line do not meet, so they are parallel. And this line here, which is a skew line for this line, are parallel to the line 3. So this line 3 and line 2 is parallel to each other. Because the definition of a parallel line, two lines which do not meet are called to be or said to be a parallel. Theorem 14. There are two intersecting lines there that can determine a plane. Two intersecting lines here can determine a plane. So we will construct a line here to prove that these two planes are parallel. So according to theorem 9, that two planes are which is perpendicular to the same line are parallel. So this line here and this line are parallel. This line here and this line are parallel. And these two intersecting lines can form a 90 degrees and also here. So the angles of these intersecting lines and these intersecting lines are equal. Theorem 15. Here there are two straight lines here that this speller and this speller. These two lines are parallel to each other, and these are cut by three planes which are the ceiling, the floor, and the ground floor. So we will construct a line here, the AE and the BEF, and CD and the DF. So the EF over EB is equal to CD and over DF. So because the two lines here, the straight lines, are parallel to each other, and the three planes which is cut the straight line are parallel to each other, and it is stated in Corollary 104. Theorem 16. For example, these two planes, the half planes and the half planes, intersect at this edge. So, what is the definition of a dihedral angle? That the angle between the two intersecting planes. So the dihedral angle here is this part, and the plane angle is this part here. So the dihedral angle is forming a 90 degrees, or it's called a right dihedral angle, and the plane angle here is also forming a 90 degrees. So the dihedral angle are equal because the plane angle are equal.
Than I've ever had. Make it all better.